gonna discuss to you one of the topics of physical chemistry. Okay, since physical chemistry involves chemical kinetics, and this topic or these topics is under also chemical kinetics. So we need to understand this further before we will understand more on the rate of chemical reaction, rate of reaction constant, the initial method rates, determination of the initial rates, something like that. So these are all about reaction mechanism and rate laws. Okay. So before going further, I need to discuss some examples of chemical reactions. So we have three types. Okay, the unimolecular, bimolecular, and termolecular. Okay, so I'll show you how. My voice is okay, right? Okay. Wait for a while. I have to get much paper. So wait for a while. I have to choose pencil pens. I have to choose here. This one. So basically these are molecularity chemical reactions. Okay, we have examples of the unimolecular reaction. This one. Okay, and we have bimolecular reaction. This one. And then we have termolecular reaction. Or trimolecular reaction. Okay. This one, guys. Okay, we have three types of molecularity chemical reaction. First, the unimolecular reactions. Second, the bimolecular reactions. Third, the thermolecular reactions or trimolecular reactions. So we need to give example so that we can understand how to obtain the rate laws in the reaction mechanisms that involves also the rate reaction constant. Okay, so for unimolecular reaction example, so we have A supposed to be unimolecular reaction, concentration A produce concentration B. Okay, so our rate law is just equal to rate of chemical reaction. Don't be confused with that terms. Okay, so rate law, small letter R, is equal to the rate reaction constant or the rate constant. Okay, and then bracket or close and open parenthesis A raised to the power 1. rate law or rate of chemical reaction is equal to the rate reaction constant K times A, concentration of A, which is the reactant, and raised to the power 1, which is the coefficient of capital A. Okay, so unimolecular reaction is the basis for the rate laws in the first order, second order, and zero order. Okay, the rate laws, for example, K is equal to, or rate law, or R is equals to K times capital A raised to the power 0, zero order. Okay, in which rate law automatically equal to the rate constant, it is zero order. Okay, and then K or R2 is equals to K raised times A raised to the power 2, the second order, or R3 or R is equals to K, okay, times A, okay, raised to the power 3. This is third order, right? Okay, no, there's no third order. Yeah, there's third order. Okay, in this situation, as long as A to B. Okay, only one reactant and one product, something like that. This unimolecular reactions. Okay, the zero, the first, and the second order rate laws are obtained in this equation. Okay, so this is the first order. First order, this one. So the overall reaction order of this one is just equal to 1. Since only concentration A involves here, so this is first order with respect to concentration A. Okay? Okay, we now consider to the biomolecular reaction. Okay, biomolecular reaction. Meaning this is two reactants or produces one product, something like that. Or it could be two reactants produces two or more products, because we are referring here for the reactants in the biomolecular reaction. Okay, so A plus A is equals to B. So one biomolecular reaction A plus A is equals to B. Our rate law is equal to, or rate of chemical reaction, rate constant K, okay, times concentration A raised to the power 1 times concentration A raised to the power 1. So R is equals to, like that, K A raised to the power 2. Like that. Our overall order is equals to 2. This one. For this reaction, our rate was equal to K, like this, A raised to the power 2. Our overall reaction order is 2. Okay, like that, A and A, coefficient 1, that is raised to the power 1 each, like that. Okay, so it could be like this also. A plus B is equals to C, like this. A plus B, A plus B is equals to C. These letters are all chemicals. Could it be a compound, or could it be an element, or could it be a gas? This is just an hypothetical, okay, examples. Okay, so it's gonna be, the rate law will be K A 1 B 1. 1. Overall reaction order is still 2. Okay. So rate law is equal to K. Okay. Reactant A. Is A coefficient is 1. So raised to the power 1. Times B raised to the power 1. So overall reaction order is N. But our order of reaction with respect to A is 1. Order of reaction with respect to B is equals to 1 because there are two different types of reactant in here, the same reactant action. Okay? And the last will be the thermomolecular reaction. Thermomolecular reaction. So the thermomolecular reaction, or trimolecular reaction, we have example A 2A plus A equals to B. Okay, and then we have 3A is equals to B. Then 2A plus B is equals to C. Like this. These are examples of thermomolecular reaction. Okay, there are 3 A's of A plus A plus A. So there are 3 reactants compounded in 1 to 1 is 3A. This thermomolecular tri. This one also 2A plus A is equals to 3. Okay, this one also is 2A and 1B. So there are 3 reactants here. 3 reactants here. 3 reactants here. Here, 3 reactants. The first will be 2 reactants of A plus 1 reactant of A. The same. Here we have 3 reactants of A. The same. That's why 3A. Here, 2A and 1B. Like this. Our individual rate for this is K, A, 2, and A, 1. So N is equals to 3. For the first reaction 2A plus A equals to B, our rate law will be like this. K, okay, A raised to the power 2 because there are 2 coefficients here, and then A raised to the power 1 because 1 coefficient here. And our rate 2 for this equals to R is equals to K, A, 3. N is equals to 3. This one. Second, 3A. So rate law is equals to KA raised to the power 3 because 3 is a coefficient. And the last will be this one. Okay. So rate law is equals to K. Okay. A to B1. Then our order of reaction, overall order of reaction is equal to 3. This one. So K or R, R is equals to K, A raised to the power 2, then B raised to the power 1. This one coefficient here. Okay, the exponent will be the coefficient, not necessarily the number of moles, okay? Because the number of moles will be balanced, but the coefficient only, okay? Something like that. Okay? So overall reaction is 3, but overall reaction or reaction order of A with respect to A is 2. Order of reaction of B with respect to B is equals to 1. The total overall reaction is equal to 3. Notice these 3 thermomolecular reactions. Each thermomolecular reaction here, here, and here have a total overall reaction order in is equals to 3. So 3, 3, 3. Okay? Like that. And now I will give an example by using now the actual or through chemicals or like elements. Okay, for example, this one. Okay, so we have now, so my question will be now, question will be show the reaction mechanism rate laws of the following Number letter A, we have O3 plus NO2 is equals to, and then letter B, H2AO2 plus iodine, like this. This is now our practice problem. Show the reaction mechanism, okay, and the rate laws of the following reaction. So in here, since this is a reaction mechanism, we will be involving reaction steps, elementary reaction steps, okay, the slow reaction and the fast reaction, or the elementary step reaction, and then the overall reaction. First, the elementary reactions composed of 2 reaction steps, and then the last will be the overall reaction, which is the sum of the 2. Okay, let's solve first. We'll show the reaction mechanism first, and then later the rate law. Okay, letter A. So we have O3 and NO2. So what is our product here? If we review our chemistry regarding reaction, okay, what's our product here? Okay, what will be our, we are here now for the production of the products. So since we have O3, expected you should have oxygen gas, right? Oxygen gas. Okay, and then you have nitrate, okay, because there's a remaining oxygen left. Oxygen gas will be here, then we have also nitrate, okay, because it's impossible that it will be going back to NO2. So it should be nitrate because NO3 is next to NO2, something like that. And NO4 is not possible. NO5 is not possible because we will start to the simplest form of products that should be protected in a chemical reaction. So it's gonna be O2 plus NO3 and O3 plus O2. And then this is rate of reaction constant 1. So ozone or O3 plus, okay, nitrogen dioxide or NO2 is equals to nitrate plus this one. Sorry, oxygen gas. Sorry. So this is our elementary step or first reaction step 1. Okay. Now our second elementary reaction step will be equal to, take note that your first product, which is NO3, should appear in your second reaction step or in your second reaction elementary step here too. So it's gonna be NO3 like that, okay? So NO3 like this. Like this. Take note, it should be added with the same NO2. Okay, not the O3, not the oxygen gas. It's the NO2. So NO3, the first, will be produced from the products plus NO2. Okay, like that. So this will be our rate reaction constant K2, like this. Now what is our product here in the NO3 plus NO2? So nitrogen and oxygen is common. So you can simply add a 2 and 2O5. Okay, and 2 and 2O5. Okay, now we need to determine which is slow reaction and fast reaction. Okay, which is our fast reaction? Here. Which is our fast reaction and slow reaction between the first reaction step and second reaction step in the elementary reactions. Here one. How can you discover that one? Okay, so the first one is the slow here, and the second will be fast, like this. Slow, fast. Okay, this is fast because usually the product is a compound, no gas. Okay, it's alone, a compound alone. Here there are two, right? The O2 and the NO, so it's divided. So we'll make it slow. Okay, something like that. Okay, like that. So our K1 rate low na ta sa 1. Rate low is equals to K1 O3 1 and O2 1 and is equals to 2. So this is our rate low in 1. Okay, R is equals to K1. Okay, this one and this one. Okay, it's very clear, right? And then our overall reaction order is 2. Since the reactants are different, we can say reaction order of ozone O3 is equals to 1. Reaction order of this NO2, yes, is 1 also. A total of overall reaction order of 2. Just add. Okay, reactant 1 is reactant 2. Okay, now our K2 or our R in reaction step 2, K2 is equal to NO3 1 NO2 1 and is equals to 2. Second order also, our second reaction step, this one, and is equals to 2. K, R, K2, NO, 2, in O3 and O2, like this, because, you know, very easy, right? This was 2. Okay, now our overall rate low, let's see, 3, R is equals to, so how can you find the overall reaction here in this 1 and 2. So we need to sum the two. The reaction step 1 and reaction step 2. So the sum will be like this. And take note what will be cancelled here, okay, in the situation. So you will cancel the NO3 like this. You will cancel the NO3. Okay, so what is being left will be O3 plus NO2 equals to N2O5 plus oxygen gas. So this is our overall. So our overall reaction now will be like this. O3 plus NO2 is equals to N2O5 plus oxygen gas. So in here, we can determine the rate law. So R is equals to K3 or just K. Okay, no problem. It depends. Or KT. Okay. K1, K2, this one become KT, or K3, or just K. It doesn't matter. Okay? It's just K. K is equals to NO2 1, O3 1. So N is equals to 2. So our overall reaction order is equal to 2, like this. R, K, N, O2 1, O3 1. This one. Okay, like that. So it's gonna be our answers. And then if there is an additional question, which is a catalyst and which is an intermediate, something like that, then you can determine also which is the catalyst, something like that. In here, the catalyst will be nitrous oxide here, catalyst, something like that. And our intermediate is N2O5 here. Intermediate catalyst in O2. Catalyst is the one who will consume first in the reaction, like that. And then it will like that. Okay. Sorry guys, because if we cancel this one, I review again. So NO2, this is 2NO2, sorry. Okay, 2NO2, so this will be 2. Okay, so 3. Our overall reaction order is sorry, I review that in O2 plus in O2 is equals to 2 in O2. So O3 plus 2 in O2, so our R will be K in O2 2, like this, O2 O3 1. So N is equals to 3. Overall reaction order is 3 in the overall reaction order total. Okay, something like that. So take note here. So I said this is the catalyst, right? The catalysts are always in the product, in the overall reaction, which is the NO2. Okay, it's consumed first, but then it's also produced later in the overall reaction order. Okay, like that. Okay. Okay, number 2, hydrogen peroxide plus iodine. Okay, this one. Hydrogen peroxide plus iodide. So let's solve. Okay. So we have H2O2 plus iodide. So what is our product for here? This This is the first reaction one. Okay. Our product is very obvious. Water plus iodine. Okay, meaning this is a single displacement or single replacement type of reaction. So this is H2O plus iodine. Okay, like that. K1. So our second reaction step will be, what is our second reaction step? Will be iodine here, not the water, huh? Iodine. So iodine plus H2O2. So H2O2 plus iodine. Okay, K2 is equals to this one. Actually, this is double displacement. Actually, but since these two compounds, iodine, and iodine is a salt or a compound, and this hydrogen peroxide contains also oxygen, contains also oxygen here. Since this is double displacement, double replacement reaction, we need to split up the oxygen gas and the iodide, something like that in the products. So it's gonna be, okay, H2O, okay, plus iodide plus oxygen gas. Now, since these are quite in the reaction step 2, since this involves 3 products here, then we need to balance the chemical reaction. Actually, we should not forget that one also. Okay, so balance the first, balance the 2. So let's visualize already. Okay, 2 oxygen, 2 added 2. Okay, 2 hydrogen, 2 hydrogen, oxygen 3, oxygen 3. Okay, balance. This is a balanced chemical reaction by visual inspection. Okay, so our rate law in 1 is equals to K1 H2O2 1 iodide 1. So N is equals to 2. For our first reaction step or elementary step, okay, R is equals to K1, okay, H2O2 is to the power 1, because H2O2 has only one coefficient, times iodide, coefficient is 1 also, is to the power 1. So 1 plus 1, this is our overall reaction order, is equals to 2. Since this iodide and H2O2 are different substances, so we need to say reaction order with respect to H2O2 is equals to 1, and reaction order with respect to iodide is equal to 1. Our overall reaction order is equals to 2, then it's equals to 2. Okay, something like that. So for number 2, R is equals to K2 H2O2, okay, then 1 iodide 1. So N also is equals to 2. With the same ratio, so K2. So R, K2, H2O2 1, reactant, and iodide 1 also. Reactant, always reactants, N is equals to 2. Now our overall reaction rate law. Our overall reaction rate law is equals to K. Since in here we don't know yet the total overall reaction, then we need to sum this reaction step 1 and reaction step 2. So it's gonna be, the sum will be, so you should cancel the what's being cancelled here is the iodide. Okay, iodide, and is gonna be iodate and iodate. Okay, cancel. Okay, iodide cancel. Iodide here. Reactant product cancel the same quantity. And iodate reactant product the same quantity cancel. What's left is 2 moles reaction. Overall reaction is equals to, let's say, 3. 2 hydrogen peroxide, let's see, K, our overall rate constant, and then 2H2O plus oxygen gas. So this is our overall reaction order. If we sum the reaction step 1, okay, reaction step 2, or elementary steps, add these two, we will obtain overall reaction order. No, overall reaction, chemical reaction goes to like this: H2O2, 2H2O2, because we need to add this one and this one, 2H2O2. 2 moles of hydrogen peroxide is equals to the rate reaction constant overall is equals to this one was left here. So 1 mole of water plus 1 mole of water, so 2 moles of water plus oxygen gas. Okay, since there is common number of moles in the product and the reactant, so we need to divide this by 2. Okay, so this is gonna be H2O, final na siya. Final reaction will be H2O2, okay, equals to H2 plus 1/2 oxygen gas. H2O2 like this, 1/2 oxygen gas plus cancel because we divide by 2 like this to make it more simpler. So our rate flow overall will be R is equals to K, okay, H2O2, N is equals to 1. What do you notice here is this is totally different, okay? Your overall reaction order, basing your overall chemical reaction, the overall reaction order is equals to 1. Imagine how many reactions here: reaction step 1, reaction step 2. Each reaction step have 2 compounds and 3 compounds or elements like that. But take note, the overall reaction order is equals to 1. So you will really break it down: reaction step 1, reaction step 2, elementary steps like an overall reaction, chemical reaction. You have to add the 1 and 2 like that, the rate low, and K1, K2 assign like that, something like that. And you will ask, what is our catalyst here? Okay, our catalyst here, is iodide. Okay, because this is being added first to speed up the reaction, added by hydrogen peroxide. So that is, iodide is our catalyst. This is being consumed first and then produced later. It will produce here. So it's still there. It will never consumed within the entire reaction, because that's the meaning of catalyst. The addition of catalyst, or the catalyst, is to use to speed up the chemical reaction or the rate of reaction without being consumed in the entire process of the chemical reaction. This is not being consumed because the iodide is still here, something like that. So our intermediate will be the iodate, because the iodate will be produced first in this first reaction step. It will produce iodate, and then later it will consume. Okay, here it will consume later, and then it will disappear in the product. There's no iodate here in the product, right? Again, our catalyst will be iodide, because iodide is being added first and consumed first, and then in the entire chemical reaction it will never be consumed because it will be produced finally in the overall reaction. And then our intermediate will be the iodate, because it will be produced first and then it will be consumed later. Okay, it's produced first in the reaction step 1 and it will be consumed later when it's being added to H2O2 again, and in the final product, it's being lost. So the intermediate will lost in the final product, that's the intermediate, and the catalyst will still remain in the final product. So that's your identification. Okay? Thank you so much for watching this reaction mechanisms, rate laws. Okay, I hope this will become your guidance in solving problems like this. Actually, this isn't really problems because these are not involving numbers, only compounds, chemicals like that. Okay, so if you like this video, then you can comment in the comment section below. Then you can subscribe my channel if you're not subscribing yet, and then click the notification bell for some news updates. I'm seeing your channel voice. Bye bye, God bless everybody. See you later.